In this video, we're going to talk about valence electrons. And so valence electrons are really just the electrons in the outermost or highest energy level for an atom. So if I take a boron atom, it has 1s2, 2s2, 2p1. But the highest energy level is 2. And so then the 3 electrons that are in that highest energy level are the 2s2 and the 2p1. So I could say that the valence electrons for boron are 2s2, 2p1, or it has 3 valence electrons. If I went to fluorine, it would now go, well, the highest energy level is 2. There's 2s2, 2p5, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. If I went to rubidium, it ends in the highest energy levels that it has is 5, and all it has there is 5s1, so it has 1 valence electron, and that's the 5s1 electron. If I do bromine, and so this is where you have to be careful. So you can see that the highest energy electrons are the 4s2, 3d10, 4p5, but because the 4th energy level is the highest energy level, you can ignore the 3d electrons here and just really talk about the 4s2, 4p5, which would give it 7 valence electrons. So the normal rule, if it's either in either of these two columns here, 1a or 2a, or any of the ones over here, is that you just look for the highest energy level, and then you go by those. So it's going to be some combination of S here, or S and P for here. So if we look at arsenic, arsenic will have 4s2, 4p3, or 5 valence electrons. Now it gets a little bit trickier when we go here. This is called the D block, and that's because these elements, right, the electron configuration ends in D. And for all of the elements here where the electron configuration ends in D, you kind of have to change the rules a little bit. So for, let's pick iron. Iron has a 4th energy level, 4s2, but because it's in this D block, you also count the D electrons, those last D electrons that it has, because these D electrons are actually the highest energy electrons it has. So this would have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Kind of weird, and we won't really talk about the D block too much because it's kind of weird, kind of unsure what to do with them sometimes, and for the scope of our course, we won't really worry about them too much. But just so you know, you would want to include both the 4s and the 3d in this circumstance. And if we did gold, you would want to do the 6s and 5d because these are the D block. And again, you can just ignore that 4f. Now, these elements down here are the ones that end in F. You can call these the F block if you wish. These ones are really like we're never going to talk about them. And there's some kind of weird things that go on. And so I'm just going to tell you right now, don't even worry about it. It's alright. You can do it next year. Okay. So, now I just want to show you a little notation thing. So let's look at over here. For our noble gases, I've just picked helium, neon, and argon, and I've listed their electron configurations. And again, you can see that they end in this filled S and P energy level, right? So this is what makes them have 8 valence electrons, 2s2, 2p6, or 3s2, 3p6. Now, any other atom we can write in a shorthand, right? So look at sodium, for example. Sodium has the electron configuration identical to neon, plus a 3s1 at the end. So all we do is you kind of put brackets around neon and say, okay, it's like neon and a 3s1. It just saves time. For phosphorus, it's like, okay, well, it's basically neon, right? This part's neon, plus 3s2, 3p3. Again, it's just shorthand. Bromine, it's basically argon, plus 4s2, 3d10, 4p5. This is just a way to write it more quickly.